This is problem number 1 on exam 2 of module 7 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 1, in many applications an ion beam is needed in which all the ions have the same velocity. To accomplish this, a velocity selector can be used. A velocity selector has an electric field pointing upwards. The ions are shot down the barrel, which is into the page. Part A, if positive ions with a given speed are to be undeflected, what is the direction of the magnetic field? The electric field is upwards, it's a positive particle. The electric force is upwards. If it's going to act as a velocity selector, the magnetic force must be downward. So our palm must be facing downward when our thumb is pointing into the page. If our thumb's pointing into the page and our palm is facing downward, the B field is to the right. This is the direction of V cross B. The charge is positive. Magnetic field must be to the right. And let's put it on the diagram. There's the B field. Part B, if negative ions with a given speed are to be undeflected, what is the direction of the magnetic field? With a negative ion, the direction of electric force is downward, which means the direction of the magnetic force must be upwards, which means V cross B is downward because the ion is negative. If we stick our thumb into the page and our palm is downward, our fingers are pointing to the right, which is the direction of the magnetic field. Same as part A. Part C, assume a velocity selector is tuned for ions moving at 400,000 meters per second. Which way is the deflection of an negative ion moving at 500,000 meters per second? So the ion's moving too fast. To get to the direction of the deflection, we need the forces. Let's put them on the diagram. The magnetic force is upwards. The electric force is downwards for a negative ion. It's going too fast, which means the magnetic force is going to win. So this too fast ion gets deflected upward. Part D asks the same thing for a positive ion. The velocity selector is tuned for ions moving at 400,000. A positive ion comes in at 500,000. Which way is it deflected? Again, we look at the forces. The electric force is upward for a positive ion, and the magnetic force is downward for a positive ion. It's going too fast. The magnetic force is going to win, and the magnetic force is downward, so a positive ion gets deflected downward. Part E, the selector has a magnetic field of 2 Tesla to the right, and is tuned for hydrogen ions moving at 500,000 meters per second. What is the magnitude of the electric field? The speed for which it's tuned depends only on the electric and magnetic fields, independent of the charge and mass of the particle. The mass doesn't appear in the equation at all, and the charge appears in both, so that cancels out. The fields depend on the charge the same way. All we have is V is A over B, E over B. The speed is 500,000 meters per second. The field is 2 Tesla. Multiply both sides by 2 Tesla, and we get the magnitude of the field, which is 1,000,000 volts per meter, or if you like, 1,000,000 newtons per coulomb. That's problem 1.